Hi guys, so continuing with a new devlog session, number 15 this time. Well, first what I need to mention maybe is I changed a bit the display of my log here. So I'm just classifying everything by devlog now. So we have number 14 through 13, and then we have the day of the work and task described for each of those. So I don't need to repeat for each task that it was mentioned in devlog 14 or whatever anymore. So that would simplify a bit the design of this page, hopefully. And now, sorry, by the way, I'm still a bit sick, so sound is going to be crappy. But you have to live with this, I guess. So what we did last time was to provide the support for this get request handling in the request manager, which is advanced get request mechanism dealing with retries and timeouts and whatever. So this is partially tested, not very extensively tested yet, but yeah, we can certainly live with that also for now. So give me a second. Okay, and what I would like to do now is maybe start having a look at this one. Adding support for JSON parsing, because we are definitely going to need this at some point. The good thing is I've already been using RapidJSON in another project where I have a kind of also a data map. So I probably can use that as a starting point to build the conversion between JSON data and AnyMap, which is what we'll need to do here anyway. So let's get to this. So oh my. Probably we're going to add a function directly in the utility, which made me think, in fact, that maybe you don't really want to keep that in utility. You could rather make this static function in AnyMap, because anyway, if you're going to use this function, you're going to retrieve an AnyMap, so you most probably need a definition of AnyMap. So it would make sense to have this right inside AnyMap itself. So am I sure about what I'm saying here? Yeah, kind of. Let's try to do this and see if it's messing too many things or not. Okay, so here we go. I have removed those two functions from the utilities file. And so remove also the implementation part. So everything containing YAML was removed from here. And I have now moved those as static function into the AnyMap here. And we have the corresponding YAML code here in the CPP implementation file. We just need to update Nerve app to use this static function now. Next, when we regenerate bindings, you get the function removed from the global function here, and they are added correctly in the bindings for AnyMap. Compilation is going on. Then on the unit test for AnyMap, we need to use the same prefix here, and this is it. We have everything in place now. I've already tested the application and run the test. Everything is off. So let's make a commit and continue on the next point. All right, so next point. So let's refresh this page. Here we are. Yeah. Not quite. Let's save this part. Check mark, and let's refresh. So we've just completed. Why are you going up like that? Oh yeah, because I want to go there. So now we really want to tackle this rapid JSON handling. How am I going to do that? No, from Firefox that would be tricky. Let me see. I need to go on my other computer. I'm going to retrieve the sources for Rapid.json, and this is in fact a component that you can place directly into your project. So I'm going to do that, and we'll discuss what need to be introduced then after this initial setup. Give me a sec. Okay, so I have now retrieved my copy of the Rapid.json repository on GitHub. And from that point, I simply took the Rapid.json from the include folder, and I'm introducing that into my NV core module. So in the sources here, we have now Rapid.json. So this is giving me a lot of additional files like that. So I'm going to commit those files, and then we'll start preparing the function we need to generate an AnyMap from a JSON file. So here is the first result for the implementation that we have provided here for parsing JSON. We have those two main functions that we introduced as static function in the AnyMap itself. So you can parse either a string or the content of a file. When it comes to parsing a string, you just create a document, parse this content, and then you go in this helper function, which I called parse JSON object, to kind of produce an AnyMap from a JSON object. When it comes to parsing a file, we do the same thing, except that we have an additional helper function to do the parsing of a file. And in this one, we will actually support comments in the file or trailing commas also, because this is something I've been using myself for configuration files. It's not standards of course, but yeah, it's pretty handy to have this available. Anyway, you do the same thing, so pass this file to produce a document, and then you go to generate an object. I mean, to produce an AnyMap from an object. So this function is a bit similar to what we have implemented for YAML handling. So you will simply iterate, check that this is an object, and then iterate on all the elements that you have, injecting the value for that element every time, depending on the type. So we are dealing with all the types that are available from Rapid.json, true, false, null, or another object here. So that's where you get to inject a sub AnyMap. If you have an array, you're going to rely on the parse JSON array, which is another helper function just above, to generate an AnyList this time. And for now, we simply inject this AnyList also. If you have a string, then it's easy. And if you have a number, in fact, with JSON, you support either 32 or 64 numbers differently. So you can proceed and inject the correct type of value here. What else? Yeah, on top of that, we have the same kind of helper function when it comes to converting an array into an AnyList. So you will simply, again, iterate on all the values and just push whatever is available as a value. Support for AnyMap is here, or AnyList also. Currently, we're not trying to do the conversion of the AnyList to another, well, unified, no specific vector type, but this would be the next step. So we will make a commit with that, and then we should also, in fact, before we modify that, or first we modify that, and then we had some additional unit testing for the JSON parsing system. So let's do that. All right, so let's review what we just changed. We have I've started with AnyMap, and in there, in fact, I started with introducing the support to push a null value, and then this was the main modification here. The idea, as we said, was to support kind of resolving, so that's the idea, resolving an AnyList before you actually push it. So we have this dedicated function now, and you're going to accept an analyst as input, and you check if this is another kind of list actually. And depending on what you get, you would push the correct version of the vector. And another major change now is that we are actually returning something from this set functions, those set functions. We are returning, in fact, the type as a string ID of what we just pushed. So I've been also modifying all the corresponding macros. So you see here when you come to set something, you return a string, and in fact, even the set any now is going to return directly the corresponding string ID, which is what we have here. So that was just to save me typing this again and returning that in this case. So I think it makes sense to just return it from the set ID base function, set any base function. So yeah, that's for the AnyMap. Modify that to return the ID. What else did we change? Then of course, when it comes to processing YAML sequence, we can just rely on this push resolve any list now instead of doing the processing again. What else? Wait a second, that's a bit stupid. I'm processing the sequence twice. That's bad. That's what it's meant, yes, yeah. So we can just remove this one, in fact. Okay, shown like that, it's a bit of a garbage, so let's switch back. And actually, if you do push it this way, you don't even need the brackets. Okay, so I removed the brackets here. And what else? Hey, wait a second. No, you don't really need brackets here because you're not... Oh, maybe here you are. And it's not complaining. That's interesting. I thought it would complain. But no. So anyway, we add this for when you pass a YAML sequence. So push resolve any list, and we have the same thing here. When you're parsing a map, and again we have that for a JSON array, and also for the JSON object. So this is it. That next I did the same kind of change in the any list because you also want to retrieve the type of what you're pushing here. And I have the additional helper function, so push null and also push. So what was I saying? And yeah, we just added the push resolve any list also in the AnyMap. So not much to add on that. The additional function is here. In the process, I also extended this a little bit because before I was only supporting integer 64, but now since we can actually have support for 32 integer or even float 32 values from the parsing of JSON files, we are also going to check for that. And next, yeah, compilation is done. What I need to do next is try to write a small unit test to check if parsing JSON is working as expected. So let's do that, and first I'll make a commit. Okay, so I've been trying to build the first simple test for this JSON parsing, and the results are currently not so good because I get a Stack Overflow issue when I try to perform the parsing itself. So I will be investigating this issue now. So I finally found what was the issue. That was simply because I was not returning anything from the parse JSON array function. So that was not good, of course. But when we fix that, there is another issue, which is that first, this is failing. I was expecting this to fail when you set it to false, but actually that's appropriate result. It's returning false. Whereas you get a failure if you set this to true, as mentioned here, which is funny because I would expect that any float 32 should be converted into a float 64. So I need to look into this. But at the same time, I'm thinking maybe I should just prevent any retrieval of a float value just here. Because the precision seems, well, yeah, it's float precision. And then if you try to convert that to a 64 value, you will get a value like this one, and you would say, okay, the precision of the source value was pretty low, whereas it was really supposed to be something like that. So probably we need to disable that. But for the moment, let's just first fix the other issue, which is that any float 32 value should be considered also a float 64. So I'm on it. So change are made, and what I've noticed eventually is, yeah, this as function is really going to check the type of the data that is stored in this any. So yeah, you can't really mix float 32 and float 64. So it's either one or the other, and it's rather when you have the get function that you can rely on more advanced logic and actually get the value, even if it's a float 32. So this was one thing. And the next thing now is I actually just disable this part because, as I said, we should really get better, higher precision than just float values anyway. So you want to get everything cast as double values in this case. And with that, unit tests are passing properly. So I'm going to make another commit with this small additional test, and we're good. Then let's see what to do next. All right, so we have provided support for JSON handling, and we can now convert any JSON file to, probably any JSON file to an AnyMap. Yeah, not quite, because we don't really support a JSON file that would be an array at the root, for instance. So probably we need to extend that someday. But anyway, what I was thinking next was to do something completely different. I could continue on this CoinGecko implementation, but right now I feel more I really want to go into this direction because I feel that I kind of definitely need to go with compilation for something running in the browser. So it's time to start looking into how Emscripten is working and how I should provide support for that in my compilation mechanism, so in the Nerve project. So let's get to it and we'll see how this goes. So I've started to look into this EMSDK. What we have to do, in fact, to get started is to retrieve this from the Git repository. So I got this Git repository, created a package out of this, and now I can install that as a simple standard tool in my system here. So the Nerve Proj framework, we have the config where we have those additional entry EMSDK here for Windows, and the same thing tool also for Linux. So those packages will now be extracted properly, and you will get this folder. And in there, from what I see, yeah, we're going to execute this file as a starting point, basically. And what's happening in there is we're just trying to figure out where is Python. So I think we can just bypass this file, and we can just provide Python and call the Python file directly here. So for that, I'm going to create EMSDK manager as another component in MVP, and we'll see how this goes. Let's go. So I've just added the EMSDK manager, which is a simple component in the project. Okay, we don't need OS here apparently. And this one currently is only providing a simple command line argument, command line function, I would say, which is the install function where you can provide a target, and then it should bring you to this line. Then I also, let's save this file, updated the config to both add the support for the script and also register the component itself with this name, so you can we can use get component later on, because I think that might be necessary when we start dealing with the compiler stuff and so on. For now, let's just try to run the install. Yeah, I was not quite sure about this point. If we provide a default, probably that's not enough, and we need to, let's remember what we need to specify. Arg and args or something. Yes, that's probably the one. Okay, so we should install target latest, and we could specify something else like my target. Okay, now time to try to deal with this. I think we need some kind of mechanism like execute. You should provide them arguments, additional arguments. So the idea is to get Python. So we need, how do you get Python? I think we need the tools first. And from tools, Python, I don't know if it's D or whatever, I don't know. Let's go into, no, come on, what did I do? Let's go into tools and see what is related to Python in there. Absolutely nothing. Get, oh, it's maybe get tool. I know I'm using Python everywhere, so get tool desk, not really what I need. Maybe I should check in no, not quite there. Get tool D, or maybe, oh, tool path, stupid me. Yes. Toolpath, so Python, that should give me the Python path. Next, Let's call that by path. Next, I need to access the file Emscripten EMSDK py. So this is in the tool folder, and it's supposed to be next to the EMSDK file itself. So in fact, in the registration process here, I'm registering the EMSDK tool package, and I have a sub path providing access to a script. So this is what we have. So where has some EMSDK? The path we'll get will be the path for this on Windows. So what we need to do now is to get EMSDK dir, which is tools, and get tool dir EMSDK. And then you have the EMSDK file, that's self get path. Get path from EMSDK dir, and the file you're going to execute is EMSDK Python. So basically, you start building your command with that. You first have Python to execute. You provide that the EMSDK file, and you may then append your additional arguments. And you would like to execute this one. Where do I handle execution? Let's see if I go there, execute git. That's very similar to this execute git. So you have a command and you're going to run execute and handle any kind of failure. Probably I should display the complete command here. Get path, okay. I'm wondering if there's no get Python path. So for now, let's just display that as info. So EMSDK command. So we have the full command. What about the folder? Yeah, probably want to use the current folder. How do we get this? Okay, I do specify an argument which is none. Maybe I should do that also. And if it's none, then you should use what is your current folder. Is it what we do here? Not really directly. We can do that directly also. So let's just use this. So just to be safe, I'm not quite sure if this is really needed, but yeah. So EMSDK command fail with return code, blah blah blah, detected them. EMSDK command failure. Sounds fair. So when we have, since we have this execute EMSDK, now we can execute this command. So you could call here execute, and the argument you want to pass are install, and then your target. And that's it. So let's see if this is working. If it's working, it might take some time, in fact. So I'm probably going to pause the recording and then get back. to analyzing what we get as output. So tar install, let's just install the latest one and we'll see. Downloading. Okay. It's not really verbose. Why would you want to download Python? Ah. Okay, you know what? Let's undo this. Portable GRE. Okay, really? I was hoping this would not be needed. Yeah, let's cancel that. And no, not here. It's in Pro, in the tools. We're going to remove this to start with a fresh version. What I wanted to do is, oh yeah, let's get this back. So to get this back, I just need to run git pull all maybe. Work, I think. Extracting, yes. So if we get back to the script, so in tools, Windows, this one, but we have this Emscripten SDK. I think we should set this variable to be safe, and so it should be set to the Python to the path to Python. So let's see how we should do that. Oh, maybe I should make a commit first to keep track of that and the changes. Let me do this. All right, so I've prepared an environment setup now where I'm also specifying the EMSDK Python path, and we just provide that to the execute function. Yeah, I mean, it's a bit of a pain. Maybe we can get a dynamic display if I run that from a batch prompt. So MVP EMSDK install. Is this working better? No, not really. So if it's not working better, why bother? Okay. So let's the download process do its things, and we'll see what is the result of that later. Okay, so I've completed the installation part. Running the install command here, I kept that a few times, so at the end I had my packages already installed here, and the latest one was a bit big, so it took some time, but it's finally downloaded and installed properly. We have that, I guess, in upstream here. And bean, we have the compiler itself. Okay, that's great. That's definitely where we need to set up things. So this was supposed to be executed from this batch file. And in the end, if there was file called setemp created, I guess, in the process, then it would be executed before it would be, well, deleted. So I think this is part of what they call the activation part, because the first thing you need to do is to do the install and to do the activation. This step here should be optional. Source the end. Let's see what we have in fact in this file. So this is necessary for maybe for Linux we need to do it. Construct env. And in there call construct env. I'm wondering what this is going to do. But anyway, let's start with executing the activate part. So we had another command for that. For now, I just remove those lines. So again, we can use a target, activation target. So we simply run activate, and that should be latest by default. That should produce the same result as this command, except that we are not executing the batch file at the end. So we'll see if it's going to generate a batch file for us. Okay. So path is going to point to the root dir, the node dir, Emscripten dir, and that's it. SDK is this node, you have the path to node. Python is redirecting to your Python, okay. Java, okay, you're setting this. And this is cleared, okay. So is this creating the batch file? Yes. Cool. So you don't really have much to set up in the end. All you really need to do is to ensure that you're giving access to the compiler, I guess, is from here. So let's see what we have in upstream and Emscripten. That's where we get, okay, the EM++ and EMCC, I guess. Yes. What is the batch file doing? Okay. So that's interesting. It means that from this point, I should be able to replicate this set and content. I think that's, no, you're supposed to call this one have construct av. What is construct av going to do? I think it's going to construct this file. Let's see if we just just rename that to old. The idea would be if we use a script, then it's going to construct the end. Since it's going to do that through the batch file, this one, if the file exists, it's going to recreate, it's going to load it and delete it. So what does it mean? It means we should have a construct. I have not registered that one yet. Yeah, I need to do it, otherwise it's not going to work. But this one, you don't have to provide any argument. So no target. Let's try construct and interesting, the order is not the same. I don't think that's really changing anything in the end. And we have the over elements set up as expected. And from there, I suppose this is also, yeah, recreating the file with the similar content as above, except that, yeah, the order is changed for the path, but that's not really important. So we will be using this batch file as a reference now to prepare the setup that we need. Let me try to start thinking about that, and we try to prepare a compiler, in fact. Let's see. Okay guys, so I've been working on the implementation of the compiler that we will use for the EMSDK system. So we start with the manager part, and in there we have a default compiler which is set to none, but then we can also get a compiler from this manager. And when you get the compiler, it's going to, well, retrieve a lot of paths. So let's have a look here. First, so you're going to check what is the directory for the Emscripten binaries. I mean script, in fact. And if it's not available, you're going to install that automatically. Then you would assume that it's available. Then you're going to find the node installation. So that would provide you the node path, which should be valid also at this point. Then you're going to search for Python also. Should be valid after that. And for the GRE installation, so you should have a valid GRE directory after this. And then you create a new compiler, which made me think that I'm still missing a few things here. Because when you get into the compiler, then there are a few changes in there also. The first part is when it comes to creating the thing. So you would have a type which is going to be EMCC this time, and then you would expect the root dir to be the location where you have the compiler scripts. So root dir is going to be this directory, which is upstream Emscripten. So you find the compiler script in there, but you need also additional elements. Let's get back in there. Well, at first you only need that. The version of the compiler I'm hard coding for the moment. I need to find a way to read this from some file somewhere. I don't know how. We're using batch file here or script file with no extension on Linux normally. This is not checked on Linux yet, so probably, I mean, it could be there would be some changes to do here. And then you have this additional function to check if this is the Emscripten compiler. A small bug fix, in fact, here. I think that when you want to get CXX dir, you can't really use a root dir. You should rather use the parent directory of your CXX path. And then when it comes to preparing the compiler environment, then that's where you have additional stuff concerning EMCC. The beginning is similar to what we do for CLang. So we start modifying the path. Actually, we start creating a path from nothing because we start with a completely empty environment. Yeah, next we need those entries. So not path. In fact, I'm not providing that. So not path. This is going to be what I just found for not path. Next one was Python path. We use Python path here. The SDK directory. That is precisely what we have as a... Oh, where am I? No. Expect what? Are you kidding me? The last one I think is a GRE directory. And with those entries, yeah, we should be able to set up the compiler appropriately because we get the path for all of them. We will be adding a couple of items in the path variable itself. So we need to add the EMSDK root directory as well as the folder where we have Node.js. The Emscripten part is already added because it's added here with a dir. And then we set up the additional variables that were described here. Then I specify what is my CC compiler, my CXX compiler, and that's it. So from that, we have the EMCC compiler already. So let's make a commit of that. And next I need to find a way to start testing this thing. So let's see. All right, so next step I was trying to do here was to perform a simple compilation. So I decided to go and try with the zlib library. And so we run the command to try to do the compilation of zlib with our new EMCC compiler. The nice thing is it seems to go pretty far in the setup. So we have CMake detecting the compiler as being CLang. Those paths are used properly, but then yeah, it stopped to fail because it cannot compile a simple program. And that kind of makes sense because it's probably trying to set up everything for Windows, which is not so good. So from there, I need to investigate further and see how we should proceed exactly to be able to do the compilation. But yeah, I was thinking that was a pretty good start already. So I think I'm going to stop here for this devlog session, and we'll continue with another one when I can make some progress on this point. So see you another time. And meanwhile, happy coding, everyone. Bye bye.